Alright, so I'm going to walk through the solutions of our practice quiz. I'm going to go kind of fast, so you can pause this video, rewind it, fast forward, whatever, later on, and adjust accordingly. I'll also post a video about how you should fill in that form at the end for your partner's quiz. So first off, we have a trapezoid. Hopefully you all knew to draw in a perpendicular. You need the height of a trapezoid. 8 is not the height, it's just one of the legs. So that'll give them a point just for knowing that they needed one of those heights. To solve for that height, you need to use a sine. So sine 38 is h to 8. You got to solve for that. So there'd be 1 point for drawing the perpendicular, a point for setting up the sine equation, a point for solving. They might have also went ahead and rounded off. That's fine. It's best to do that at the end though. The next point will be you have to show your formula in one shape or form. You've got to show how are you going to get your final answer. Why use this versus base times height versus 1/2 d1 times d2. So they need to either have the bases added together times height divided by 2 or the numbers showing there. That way we know it's the trapezoid formula, not some other formula. And then the final answer, they should have 59.1. They want it to the nearest tenth. One other thing, they need yards squared. If you do not have yards squared, take off a 1/4 point. And yes, we're going to do that for every single area problem. You have to have units squared. Area is measuring something completely different than what we're used to. It's not a length, it's now a square unit. Next we have a rhombus. They told us that the perimeter is 116 and one of the diagonals is 42. Based on that information, they should have some kind of picture like this. They should have drawn a rhombus where they have some of the diagonal parts and each side is 29. That's because 116 divided by 4 is 29. A rhombus, all of the sides are congruent. So I'll give them 2 points if they have some kind of picture where they've labeled up the sides, the diagonals. You could have picked the horizontal diagonal to be 42 or the vertical one. It really doesn't matter. The next point, they need to somehow come up with the other part of the diagonal. So we have a right triangle here. We can use Pythagorean theorem. So we're going to do a squared plus b squared equals c squared. They should get a 20. Now if they just wrote a 20 and they don't have any of this work, I'd say take off 1/2 a point because they need to show how they came up with that. But that's going to be used to get the other part of our diagonal. Next point is going to be they need to show the formula. It's a rhombus. So you got to use the rhombus formula in one way, shape, or form. 1/2 d1 times d2. Well, if the first diagonal is 42, the other part we found was 20, so this is going to be 40. So 1/2 42 times 40, that gives you 840 meters squared. Again, if they don't have meters squared, if it's just 840, you have to take off a 1/4 of a point. If they found the area of one of the triangles and then multiplied by 4, that's another method. That's totally fine, just as long as they show 1/2 base times height and they have the correct height and base. Question number 3, we have a parallelogram. All opposite sides are parallel. Same kind of trick, we need to draw in the height. So first point, they should have a sine equation. Sine 65 equals h over 13. There is a way you can get this angle and then use a cosine. What's that going to be? Cosine of 25 equals h to 13. And you get the same answer. I think sine's a little easier. So 1 point for setting up a trig ratio equation, 1 point for solving. Next point, they need to show their formula somehow, base times height. So 32 times 13 sine 65. The reason why we use the 32 and not the 13, those are the things that are perpendicular to each other. The height perpendicular to the base. This would be our final answer. They need to have feet squared. Take off that 1/4 point if they don't have the units squared. On our circle problem with the shaded area, we've got this larger circle with a diameter of 14. They should have somehow in their calculations for that area shown a 7 for the radius at some point. So if they showed it somewhere in the formula, that's fine. Just as long as you see a 7 associated with the radius for circle B, that'll give them a point. Next point, they should have pi r squared. Just square the 7 and put the pi on there. And then for circles A and C, they're going to have the same radius. So the radii of those are going to be 3.5 each, because if the radius of B is 7, half of that is 3.5. And then the next point they're going to get by plugging into that area formula, pi times radius squared. And then what we're going to do is they need to show somehow that they came up with the shaded area. They have to do big circle minus the 2 other circles. Real common mistake is they forget to have that 2 on there. I've got 2 of those circles, so I have to subtract them off. Then we're going to get 77. They want it to the nearest square millimeter. That means the nearest whole number. So they should have 77 millimeters squared. Up here, if they only subtracted 3.5 squared pi, I'd give them half a point because they kind of knew what to do. They just forgot that they need to subtract more than what they have there. On the second page, this question number 5 was kind of tricky. You've got to draw that altitude, and we've seen this question a bunch of times on a couple of other tests before. So you got to draw the altitude. You're going to notice if that's 120 and they told you that's 30, and the directions, A is 30 degrees, well, that's going to tell you this angle is also 30. You have an isosceles triangle. So when you draw the altitude to an isosceles triangle to its base, you always bisect that side and you bisect the angle. You get a 30, 60, 90 triangle. And so you could just use the pattern for 30, 60, 90. I just set 3 points for a picture like this. I'd say like 1 point for drawing the altitude, a point for coming up with 11 root 3, and a point for coming up with 11. That should be totally fine. And then the next point is going to be show the right formula. Got to have 1/2 base times height to get area of a triangle. And then in either form, either just with the variables there or just plugging in the numbers you got, you should get, at the end you should get 121 square root of 3 meters squared. If they rounded this off in their calculator, take off a 1/4 point because it didn't tell us to round. And then if they forgot meters squared, also take off that 1/4 point. Down here we have a regular pentagon inscribed in a circle. First thing we need to do is find the radius of the circle. So that's going to be a sine equation. They should have that's 54. That whole n minus 2 times 180 business, that should be kind of like second nature by now. So first equation to find the radius, so they got to solve that thing. They'll get 12 over sine 54. And then the area of that circle should be radius squared times pi. I know that's an ugly looking radius, but that's just how it goes sometimes. Next equation, we need to find that side length or that portion to come up with perimeter. I just put an x there. They can use any variable they want. So tan 54 is 12 to x. Got to solve that thing. And then the next point is using that to get your perimeter. Now they might have rounded off in their calculator. That's fine, but it's always a good idea to wait to the very end to round because then you get the most precise answer. My perimeter is going to be 5 of 24 over tan 54. The reason why I now have 24 instead of a 12 is x is just that part. That means 2x would be one side length. So that's 24 on top instead of just a 12. That means that the area of my pentagon is 1/2 perimeter times apothem. So they should show that at some point. If they rounded off early on, I just kind of put those numbers down, about 691 point blah 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 for the circle, about 523 for the pentagon. They should state somewhere like how they came up with their answer. You know, they subtracted them, and this should be their final answer, 68.1 feet squared. Same story with the unit squared, you gotta have them on there. Last one here, first point would be this proportion. They need to have area to area is a squared to b squared. It's not a over b, area you do squared to square. So to solve that, they should have taken square roots, so give them a point for that, and then they should reduce that thing. The top reduces 5 root 3, the bottom reduces to 4, so right here is our scale factor of big octagon to small octagon. Next point is going to be setting up the correct proportion. So scale factor, so big to small equals big to small. And then from here you got to cross multiply. I know that there's some ugly looking expressions here, but that's just how it goes sometimes. They got to use that algebra to solve for x. It should be 10 squared of 3 minus 4 in the numerator and then 8 in the denominator. If they round it off, I'd say take off a 1/4 point. I don't remember what that value is, but they should come up with this value for x in inches. Okay, I'll post another video for how you can grade this on that sheet.